how to simplify them. So that was when we were simplifying singular rational functions. Mariana, can you hit the light switch over there while you're over there? Thank you. All right. So today we're going to actually focus on multiplying and dividing rational functions. Now, this is the same concept as multiplying and dividing simple fractions. So let's review this real quick. So if I asked you to do 1/2 times 2/3, it would help if I didn't freeze it. So if I asked you to do 1/2 times 2/3, you don't need to write this down, but how would you solve this? Or you can write it down if you want to. How would you solve this? What would you do to multiply those two fractions? Not cross multiply.
You would do 1 times 3 times 2. That's cross multiply.
Not with multiplying fractions. You don't cross multiply. You multiply straight across. So you do 1 times 2 and 2 times 3. So that would give you 2 over 6. And the reason I'm telling you to do that instead of cross multiply to simplify it down first is because it'll make your life a lot easier when we do the rationals. So we're doing it the long way. So you multiply straight across, you do 1 times 2, 2 times 3, you get 2 6, which that simplifies down to what? 1/3. All right. Now, what if I asked you to divide them? So you do 1/2 divided by 2/3. How do you divide fractions? Not quite. I'll give you guys a hint. Kentucky Chicken Fried. KCF. What does KCF stand for math-wise? Keep, change, flip. Good. So we keep the first fraction, change the division sign to multiplication, and flip the other fraction. So this would be 1/2 times 3 over 2. So then we do the same thing. We multiply it across. So you get 3 over 4. And then that can simplify down. So keep this stuff in mind because this is essentially what we're doing when we're multiplying and dividing rational expressions. It's the same concept, just a whole lot more steps. All right. So we're going to start with the actual multiplication. So we're just going to jump right into the examples. Before we do anything, all right, before we start doing any crossing, any multiplying straight across, what did we start with yesterday when we were simplifying rationals? We always did what first? So when we simplified rational expressions yesterday, what did we always do first? Well, yeah, GCF, but what are you doing? Starts with an F. Factoring. We're going to factor all of the parts of the two fractions. Because once we do that, it's really, really easy. So your first step is to factor everything. All right. So the numerator of the top is pretty easy. Because what are two factors of -8 that add or subtract to -7? -8 and 1. Good. So that means this would factor to x minus 8 times x minus 1, or plus 1. Oh, yes. Oh, that's right. You weren't here yesterday. So that's the top part. The bottom part of that fraction. All right. What's the bottom part of the fraction? It's a what? It's a difference of squares. So how would I factor it? Someone besides Landon. Take a minute, factor it on your own. It's a difference of squares. So how would you factor it? So, guys, this is why I said you got to be really comfortable with factoring because you got to be able to do this quick. So, it's a difference of squares. So, how do we factor it? You take the square root of both. And then you do a plus b, a minus b. So, there's going to be a plus here, a minus here. What's the square root of 1? 1. So, this will be 1, 1. What's the square root of x squared? X. So, this will be x and x. Times. All right. Then we're going to do this one. So 3x squared minus 4x plus 1. We're going to do a quick big X. So if I do a times c on top, what do I get? 3. What's on the bottom? Negative 4. What are two factors of 3 that add to negative 4? 1 and 3, and they're both what? Negative. So I have negative 1, negative 3. And then we're going to do a quick reverse box. So I'm going to throw an X on the end of these. This is 3x squared, positive 1, and then we're going to put negative 3x here and negative 1x here. But again, the placement doesn't really matter for those two. So what times what can give me 3x squared? So we want both variables to have an x in it because x times x is x squared. But what times what gives me the 3? 1 and 3. So we're assuming that somewhere in this we're going to have a 3x times x somewhere. Now, the placement depends on what's going on with our box. So if I put the 3x here, would that work? No. Why? Right, because there's nothing times 3 that would give us a negative 1. That's a whole number anyway. So I would have to put the 3x here, which means the 1x has to go here. Now, the rest of it's easy because 3x times what is negative 3x? Negative 1. And then x times what is negative 1x? Negative 1. Thus, my factors are what? 3x minus 1 and then x minus 1. All right. Then lastly, we're going to do the bottom one, which the bottom one is a what? It's a difference of squares. So how would I factor it? So what would it be factored? You have to take square roots and then put it as a plus b, a minus b. All right, so this would be 3x plus 1, 3x minus 1. Does everyone understand how I factor those? Yes, no, maybe, speak now, forever hold your peace. So all I did was just factor these. So I'm going quick on the factoring because, this should be something that you guys are already fairly familiar with. So if you don't, you need to tell me now. Like if there's any part of this that confuses you, you need to tell me now and I'll help you. All right? Now, there's one other thing I want to deal with before I start merging everything. The blue part right here. I want it so that the x's are in front. So I'm going to do a quick rewrite. So if I rewrite the blue, I would get x plus 1 and then negative x plus 1. What could I factor out of one of the terms to make the x positive? So I want to make this x positive right here. What could I factor out? A negative 1. So, and the reason you'll see why I'm doing this in a second, but I would get x minus 8 over x plus 1 all over negative 1 x minus 1, because I factored a negative 1 out of the negative x plus 1, because I want the x to be positive, times x plus 1, times 3x minus 1, x minus 1, all over 3x plus 1 times 3x minus 1. So now everything is factored. Now, we're going to do the multiplying fraction method, which means you just multiply straight across. And it's really easy because all you got to do is just condense all of these factors into one big fraction. So if I was making this into one big fraction, this is our second step. We're making it into one big old fraction. So what's going to be on the top? So just list all my factors that are on top pretty much. What's my first factor on top? X minus 8. What's the next one? X plus 1. What's the next one? 3x minus 1. What's the next one? Good. So all I did, guys, is that multiplying these fractions are very easy because all you got to do is just basically condense the top and the bottom into one fraction. You basically are just taking away the multiplication symbol and extending that denominator bar or that fraction bar. So then what's on the bottom? So guys, what are basically all my factors in the bottom of the fraction bars? Yep, we just connect them all. So this would be negative 1 times x minus 1 times x plus 1 times 3x plus 1 times 3x minus 1. And the reason we're doing this is once we simplify it into one big fraction, remember what we did yesterday with simplifying rationals? What do? So when we simplify rationals, what do we do once we get to this phase? Let's look back at your notes from yesterday if you need to remember. But this is now one big fraction that we can simplify. How did we do it? Landon.
Cancel out the factors that are the same.
Right. Cancel out or cross out the factors that appear in both the numerator and the denominator at the same time. So what is one set of factors that appear in both the numerator and the denominator that I can cross out? X plus 1. So x plus 1's gone. What else? 3x minus 1. There's one top, one and bottom. They're gone. What else? X minus 1. Those are gone. Anything else? All right, so we're pretty much done. Now, what am I left over with? So what's left over? Over negative 1 times 3x plus 1. Now, since we have a negative 1 on the outside, I'm going to move that to the top and multiply it to the numerator. The reason is that, like, you can move a negative 1 anywhere because it just makes the entire fraction negative. Like, we know that that negative 1 exists. So if I make this negative 1, or negative times x minus 8 all over 3x plus 1, I'm going to distribute this negative real quick, and I'll get negative x plus 8 all over 3x plus 1. Can I simplify anything else there? What do you guys think? Am I done? So let me ask you guys this. Can I cross out these x's right here? Yes or no? No. Why? Technically, they are the same. X and X are the same. But why can I not cross them out? Nope. Not because of the number in front of them. We could still get rid of them regardless. Not necessarily. Again, that deals with the number in front of it. So recall when we talked about polynomials. What did I say happens when you have two terms that's separated by a plus and a minus? They are what? Dun, 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 dun. They're married. So if you have two terms separated by a plus and or a minus, which both of these are, that means that these terms are married together. All right? These are together and these are together. We cannot break them apart. The reason that we can like essentially delete all of these guys up here is because they're being multiplied to each other. So we can cross out whole factors because they're being multiplied to each other. But once we get to here where they're just being added to each other, we can't do anything else. So this is our answer. Our answer is negative x plus 8 times 3x plus 1. Any questions on that one? So guys, the hardest thing about these problems is the actual factoring. After that, it's just a lot of crossing out. All right. Yes. Go ahead. So, like I said, the biggest thing you got to get comfortable at, and you got to keep practicing is that factoring. All right? Because if not, it'll just make your life a lot harder. All right? Any questions on the first part? All right, let's do the second. So, now we're dividing. So, what do we do when we divide fractions? What's the first thing we do even before we factor? So, when we did the little numerical fractions up top, when we were dividing them, what did we do first? Right, keep, change, flip, so we can do the multiplication. So, you want to keep the first, change the division to multiplication, and flip the second fraction. So just remember KCF, KCF, Kentucky Chicken Fried, keep, change, flip. All right. So we're going to rewrite this before we even start factoring. So this is x squared minus 6x plus 8 all over 3x to the fourth minus 6x cubed times, because the division now becomes multiplication. And then we flip this fraction over. So this is 2x cubed minus x squared all over 4x squared minus 1. All right. So now we have a multiplication problem. So we're going to repeat the steps that we did in the previous. All right. So what's my first step? We got to just factor. All right. So let's go through this together because this one's actually a little bit of a quicker factor. The first numerator, so this one right here. Remember, we can use the shortcut method. So we really need to only find two factors that multiply to 8 and add to negative 6. And then we can write our factors as, if I turn the highlighter off, as x something plus or minus something, and then x plus or minus something. What are those two numbers that would multiply to 8 but add to negative 6? Negative 4 and negative 2. So all we do, since our a value is 1, is we're just going to put negative 4 next to the x, negative 2 next to the x. And that's it. It's factored. All right. What about the denominator of that fraction? So this one right here. It has a GCF of what? 3x cubed. So 3 can go into both 3 and 6, so we can pull a 3 out. And then each term has at least one x cubed, or at least 3 x's that they share. So we can also pull out an x cubed. So if I divide both of these terms by 3x cubed, what's 3x to the fourth divided by 3x cubed? X, because the 3's cancel, and then x to the fourth. If you take 3 of the x's away from x to the fourth, you're left with a singular x. What's negative 6 divided by 3? Negative 2. What's x cubed divided by x cubed? Nothing. It goes away. The x cubes cancel. All right, so that's our first fraction factored. Now what about the second? So the numerator of the second fraction, what do I have there that I can take out? I can take out an x squared. So if I take out an x squared, I'm going to divide both terms by x squared. So what's 2x cubed divided by x squared? What am I left with? 2x, because 2 divided by 1 is 2. X cubed divided by x squared. You took 2 x's away from the 3, so you just get a singular x left. Now what's negative x squared divided by x squared? Negative 1, because the x squareds cancel out, so that's all you're left with is a negative 1. And then finally, our last part that we need to factor is the 4x squared minus 1. What type of binomial is that? What do you notice? It's a difference of squares, because 4x squared is a perfect square and 1 is a perfect square. So how do I factor a difference of squares? A plus b, a minus b. So we know we're going to do something a plus b, a minus b. So we're going to take the square root of both to get our a and b. So I'm going to put a plus here and a minus here. What is the square root of 4? 2. What's the square root of x squared? X. So this would be 2x and 2x, because that's my a value. What's the square root of 1? 1. So this would be 1 and 1. So guys, does everyone follow the factoring part? How I did it? Kind of, sort of, maybe? So when you're doing this on your own, if you need to take all the extra steps, that's fine. All right? You don't have to do it as fast as I'm doing it. But the reason I'm doing it fast is because I actually have to get to the part where we're, simplifying. Because the factoring, you guys have been doing it for about 2.5 years now. So you kind of have to be fairly okay at it. All right? So, what's my next step after this? What do I have to do? Not yet. We got to do something else first. We got to make it into a big fraction. So, my suggestion to you guys is if you have any monomial, meaning one-term GCFs, I would move it to the very front of your fraction so you just know it's there. So I'm going to write this as x squared times x minus 4, x minus 2, times 2x minus 1. And the reason you can do that is because of the commutative property of multiplication, meaning that wherever you move the numbers in a multiplication problem, it will still give you the same answer. For example, 3 times 2 is the exact same thing as 2 times 3. All I did was switch the place of the numbers. Still gives you the exact same answer. They both equal 6. Same thing here. You can move the factors around. You still get the same thing. All right, then the bottom would be 3x cubed, x minus 2, 2x plus 1, 2x minus 1. So now we're at the step where we can start crossing things out. So what is one factor that I have in both the numerator and the denominator? X minus 2, so those go bye-bye. What's another factor that I have in both the numerator and the denominator? 2x minus 1. So those are really the only factors that I have in common. So then I'm going to write everything together again. So I have x squared times x minus 4 all over 3x squared, or 3x cubed, sorry, times 2x plus 1. Now, before we do any distributing to fully simplify, is it fully simplified first off? Is there something else I could get rid of? So is there something else in this expression that I could get rid of or cross out? You sure? The x squared. Why can I cross out x squared? Right. We can simplify this fraction right here. Because since we have an x squared and an x cubed, one the numerator, one the denominator, we can just do some monomial division to get rid of the x squared up top. Because remember, if you subtract them, if you took away 2 x's from the bottom, what are you left with in this x cubed if you took 2 of them away? 1x. So this x squared goes bye-bye, and then we're only left with a singular x. So this is actually equal to x minus 4 all over 3x times 2x plus 1. Now, we're still not fully simplified because I need to distribute this 3x back into the set of parentheses just so everything's nicely cleaned up. So I'm going to just distribute it very quickly back in. So this will be x minus 4 all over 3 times 2 is 6. X times x is x squared. 3x times 1 is positive 3x. And now we have a nicely simplified expression. So guys, the problem with rational functions is they're very, very step heavy. All right? The factoring alone can take a while. All right? But the simplifying, once you get it together where you can just start crossing stuff out, the simplifying's easy. But you still got to ask yourself when you finish crossing things out, am I done? Is there anything else I can get rid of? As long as it's within multiplication, you can get rid of it. As long as it's not connected by a plus or a minus, you can get rid of it. If it's connected by a plus or a minus, you can't touch it. They're together, they're married, you can't separate them. All right? But the reason that I could have gotten rid of these x squareds and x cubed, the reason I could have gotten rid of these two is because it was technically being multiplied to this term, and the x cubed was technically being multiplied to this term. And even though the x cubed was connected to the 3, it was connected to it by multiplication. So multiplication and division are kind of like, put this in terms you'll understand. Multiplication and division is almost like an open relationship. All right? They can go with whoever they want. They can, cancel each other out if they want. They're a little floozy. They go wherever they want. Whereas addition and subtraction are more like a pure Catholic marriage, all right? If y'all know what I'm talking about, like divorce is like pretty much non-existent, like you can't separate them. So that's why these two terms you can't break apart. They are forever married, you can't touch them. But these you can break apart because this term's being multiplied, this term's being multiplied, and the 3 is technically being multiplied to the x cubed. So the x cube's going to screw the 3, I'm going to go with the x squared, bye-bye. But only 2 of the x squareds went. So, again, weird way of looking at it, but sometimes that's kind of putting it in those terms kind of help with the visualizing. All right. I know y'all like a little bit of drama in your lives. All right. So you want to think math as a dramatic soap opera, go for it. All right. So let's try one on our own. So very quickly, I want you just to try and attempt letter C on your own. So just try it. Take a couple of minutes. Just try it on your own. Yep. Uh-huh. So start with the key change flip because it's a division, and then start with the factoring. All right, guys. At the very least, at this point, you should be done with the factoring at least. Because 2 factors of 8 is more to add 6, but it's negative 6. Meaning that you can change both of things to be negative. So I'm looking at this somewhere or the last. So you look at the last one and figure out what your signs have to be, whether they're the same or opposite. If it's a plus, they're the same. If it's a negative, they're opposite. And then the B sign tells you whether they're going to be positive or negative, or in the case of this one, which number is going to be the negative one, which is going to be a positive one. Now, can't distribute this yet. That. So hey, if you got down to that, that's pretty good. Okay, guys, I'll give you another minute.
What's it mean?
What you did for your cards.
But those things make sense. This is.
You're just factoring the numerator and the denominator separately. So you only focus on factoring the numerator, then you factor the denominator with both fractions. You just do it separately.
I can't factor it.
Okay.
Well, I don't know how.
All right, guys, check your answer.
How?
So let's just talk about this. The first thing you should have done was keep, change, flip because it was a division problem. And once you did keep, change, flip, you should have gotten this. All right. Now, the factoring. The first numerator, you need two factors that multiply to give you -8, but add to give you 2. And the reason we can do that is because our a value is 1 in front of the x squared. So that would have been 4 and 2, multiply give you 8. And since we want -8, one of them has to be negative. So in reality, we're subtracting to get to the positive 2x. So since it's a positive 2x, that means the 4 had to be the positive one. Because if the bigger number is positive, that means you'll get a positive answer when you subtract. So we had x plus 4, x minus 2. The second denominator, the only thing that we could have factored out was a GCF of 8. So that's what I factored. I took out a GCF of 8, that gave me x minus 2. On the other side, only thing I could have factored out of the top numerator was a 2. So I took the 2 out, I get x plus 5. Bottom one was a difference of squares. So you would take the square root of the first, square root of the second, square root of x squared is x, square root of 16 is 4. So you would have written it as x plus 4 times x minus 4. So once you get the two square roots, you separate them. One factor separated by a plus, the other one separated by a minus. Now, when I got here, I just rewrote it so that all my factors were in one fraction. So I moved this GCF of 2 to the front just so I could remember that it's there and I can see it. So I got 2 times x plus 4 times x minus 2 times x plus 5 over 8 times x minus 2 times x plus 4 times x minus 4. So when you cross them out, there's an x plus 4 on both sides of the fraction bar. There's an x minus 2 on both sides of the fraction bar. All right. So I got 2 times x plus 5 times 8 times x minus 4. That's what I have left. Now, I saw a lot of you get to here. And some of you went ahead and started distributing back. But we can't quite do that yet because 2 and 8 on the outside, since they're being multiplied to be x plus 5 and x minus 4, they're still separate from those two bubbles. So in reality, we can simplify the fraction 2 over 8, which simplifies to 1 over 4, which is how I got x plus 5 on top, because that's just 1 times x plus 5, all over 4 times x minus 4. So I simplified this fraction to get this, and then to clean it up, I distributed the 4 back into the bubble to give me x plus 5 over 4x minus 16. And I'm only left with terms with pluses and minuses separating them. I can't cross anything out. There's no more multiplication. If I factored a 4 out of this, I'd end up with what I started with. So we're done. Any questions? All right, so you should have the skills now to finish up that Delta math from yesterday. But since we only got about 10 minutes left, I'm just going to give you your exit ticket because it's going to be another one of these. So more practice. So this one's actually a little easier. You're welcome. So you don't have to factor the first fraction. The only part you have to factor is the second fraction. All right, so the first fraction you don't even have to factor.